Students, class 10. Today we are going to see the coordinate geometry. First of all, in coordinate geometry, what we learned in the lower classes, we just recall about that. First of all, the distance between the 2 points and then the midpoint, centroid and section formula we have already studied in our lower classes. Just we recall about that. The distance between the 2 points. See, the distance between the 2 points means, if the line is given means we can measure the line and then we can able to say what is the length of the line. Instead of here the 2 points is given A and B, then the 2 points are as a coordinate points. Coordinate point means we know that X and Y is the coordinate point, right? So here we have 2 points. So first point we take it as x1, y1 and then second point we take it as x2, y2. When the 2 points are given, how to find the distance between the 2 points means we have the formula. The distance between the 2 points d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square units. Here we are measuring that. So here we have the units. So x2 minus x1 plus here x2 minus x1 whole square and then y2 minus y1 whole square is the formula. Here the same as we can rewrite the formula as like x1 root of, here we have taken the x2 minus x1, right? Then x1 minus x2 whole square plus y1 minus y2, both are gives the equal values because here we have squaring the term, so we cannot get the negative value. When we are squaring, we cannot have the negative value, we get only the positive value. So we can use the formula x2 minus x1 whole square or x1 minus x2 whole square, right? And then we have the midpoint. Midpoint formula is what we are studying in the lower classes, right? The same here, the line is given, here A and B 2 points are given. Suppose the length is given means, if the length of this line is 10 meters given means we can divide by 2, right? Divide by 2, we can say this is the midpoint is 5. Here the 2 points is given x2, x1 comma y1 and then x2 comma y2 means here we are going through the same concept. Add the coordinates of x1 plus x2 and divide by 2 and then y1 plus y2 divided by 2 is the midpoint of the formula. So midpoint we take it as m of x comma y is equal to, we have the formula x1 plus x2 divided by 2 comma y1 plus y2 divided by 2 is the midpoint of the line, right? Now we see the section formula. Section formula we have internally and externally the ratios, right? Section formula, if the line has the 2 points, that is one of the point is A, x1 comma y1 and then the B point is x2 comma y2. The point P lies in any of this line, that is the point P. We want to find out the point P in the ratio m is to n ratio, because we don't know the length of what is AB and what is PB, right? So we take the ratio. So by section formula, it internally means P of x comma y is equal to m x2 plus n x1 divided by m plus n comma m y2 plus n y1 divided by m plus n. If the point intersect internally in the ratio, right? Suppose it is externally means we have the P of x comma y is equal to, instead of plus we have the minus, right? So m x2 minus n x1 divided by m minus n comma m y2 minus n y1 divided by m minus n. The point intersect internally in the ratio means we are using the plus, externally in the ratio means we are using the minus symbol. Let me see the centroid of the triangle, right? Centroid of the triangle. See, in a triangle, the three vectors points is given. That is, A is taken as x1, y1, and then the B point is given as x2, y2, and then the C point is given as x3, y3. Now we want to find the centroid. First of all, the centroid is the midpoint, the median of the concurrency point is the centroid of the triangle. See, if a line is drawn, the median means midpoint of BC and then the midpoint of AC. If you draw the line like this, midpoint of AC and then midpoint of BC, we have the line, the median of the triangle, the point of concurrency is called centroid G. We denote it as a G. Here we have the centroid G of x, y. We have the formula. It always divided the ratio. The smaller portion we take as 1 and then the longest portion we take as 2 ratios. Right? So we have the formula, that is x1 plus x2 plus x3 divided by 3. The ratios. If you apply the section formula, we can easily find out the formula also, right? And then y1 plus y2 plus y3 divided by 3 is the centroid of the triangle formula. Now we see how to find the area of the triangle. In lower classes, the area of the triangle, the sides measurements are given. We can easily able to find of base into height is the formula. Instead of here not giving the measurements, instead of measurement, here the points are given. How we are going to find the area of the triangle? Let's see that. Let me take the triangle. In a triangle, instead of the measurements, the sides measurement, here the points are given. 3 vertices points are given. Let me take it as x1, y1, and then B point as x2, y2, and then C point as x3, y3. Now here we have the formula, area of the triangle ABC is equal to half into the absolute value of this triangle. Let's see that. Area of triangle is equal to half into, let me take it as, this is the point x1, y1, and then x2, y2, and then x3, y3. Again we take it as x1, y1. This is the easiest way to find the area of the triangle. When we are finding the area, we have to use the units as square units. So here we have 3 points only, right? So area of the triangle, this is the formula, that is area of the triangle half into x1, y1, x2, y2, x3, y3, and then x1, y1. By using this formula, we can be able to find the area of the triangle when the 3 points are given, not the 3 sides measurements, right? When 3 points are given, this is the method to find out the area of the triangle. Now we can be able to find out area of the quadrilateral. Suppose here we have one more point, right? Let me take it as D as another point. D point we take it as x4, y4. So here area of the quadrilateral, we have the 4 points, right? Area of the quadrilateral as formula, area of quadrilateral is equal to half into, here the same x1, y1, x2, y2, and then x3, y3. Here we have 4 points. Fourth point is x4, y4. Again we come to the x1, y1 square units is the area of the quadrilateral, right? Let's see in the problems. Students, exercise number 5.1 in coordinate geometry. See the question number 1. Find the area of the triangle formed by the points. Here the 3 points are given: 1, -1, -4, 6, and -3, -5. Here in lower classes we have the measurements are given by using the formula of base into height. We can able to find the area of the triangle. Here the 3 vertices points are given, right? Now we will have to take the vertices points in an order. See, for example, roughly we take it as the xy plane. This is x-axis, this is y-axis, and then we know that the first quadrant is always both positive, and then second quadrant we have minus, plus, and then third quadrant we have both minus, and then fourth quadrant we know that plus and minus. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? Now we can roughly place the given points and take it in a order. Then only we can be able to get a positive value. Otherwise, if we get the negative value also, here we have the area of the triangle is always the absolute value. Absolute value means there is no negative value. In case you get the negative value means you just change it into positive and write the answer. That is the one of the method. Now we have to take it in order. See, here we have plus minus. Where it is plus minus means this is the point. This is 1, -1, and then minus plus. So here we have second quadrant. We have minus 4, 6, and then both negative. We have the third quadrant. This is the point -3, -5, and we have joined this 3 point. We get a triangle. Now we want to find the area of this triangle. Now the point should be taken in a anti-clockwise direction. So let me take that this is A, B, and then C points, right? Let A as 1, -1, and then the B point as -4, 6, and then the C point as -3, -5. We know the form of our area of the triangle. So area of triangle of into x1, y1, and then x2, y2, then x3, y3, and then x1, y1. Here we are finding the area of the triangle. So use the unit as square units. Now the first point we take it as x1, y1, and then second point we take it as x2, y2. The third point we take it as x3, y3. Here the given points are a coordinate point. Combination of x and y is the coordinate point. So x1, y1, x2, y2, x3, y3. Now apply the values in the formula. Now this term is equal to half into what is x1? See, x1 is equal to 1, y1 is equal to -1, and then x2 is equal to -4, y2 is equal to 6, x3 is equal to -3, y3 is equal to -5, again x1, y1, that is 1 and -1. Now we have to multiply the terms. See how to multiply. First you multiply these two terms like this. 1 into 6 is 6. Here minus into minus plus 4 5s are 20. Minus into minus plus 1 3s are 3. And then minus of the second term. The first term is completed, and then minus of the second term. The second term should be, this is the second term. You have to multiply this term. So minus into minus plus 4 ones are 4. Here minus into plus minus 3 6 are 18. Here plus into minus 1 5s are 5. First the multiplication is completed. Next we simplify the terms. This is half into 6 plus 20 is 26, plus 3 is 29, minus, here we have the negative value. So minus 18 minus 5 is minus 23, and you have to add 4. Here we have the different symbol, so subtract this 2, we get minus 19. So minus 19. Next step, remove the bracket here, we get the value as see, this term is equal to half into 29. If you remove this bracket, we get minus of minus. Minus into minus is plus and then 19. Now sum of this value is equal to 1 by 2. Add this two term 9 plus 9, 18, 8 remainder 1. 1 plus 2 is 3 plus 1 is 4. It is 48. Now divide by 2. 48 is divided by 2, we get 24. Therefore 24 square units is the answer. Hi students, exercise number 5.1 in coordinate geometry. Let's see the question number 2. Determine whether the sets of points are collinear. Here the 3 points are given. First of all, the collinear means all the 3 points are lies in a same straight line. All the 3 points are lies in a same straight line. Then only we can say it is a collinear. Here the 3 points are given, but here we are going to use the concept of area of the triangle. The 3 points are, first of all, the 3 points are collinear means we cannot be able to form a triangle, right? If it is not able to form a triangle means then the area of the triangle is equal to 0. Then we can say the 3 points are collinear. If the area of the triangle is not equal to 0 means then it is not a collinear point. Let's see the points. Let me take it as the first point A as minus 1 by 2, 3, and then the second point B as minus 5, 6, and the third point C as minus 8, 8. By the formula of area of the triangle ABC is equal to half into, we know the formula, that is x1 y1, x2 y2, x3 y3, then x1 y1. Here we are finding the area, right? So use square units. Now let me take it as the first point as x1 y1, and then the second point as x2 y2, and then the third point as x3 y3. Now substitute the values of x1 y1, x2 y2 and x3 y3 in the formula. Then we get half into, here we have x1 y1. x1 is equal to minus 1 by 2, y1 is equal to 3. Then x2 is equal to minus 5, y2 is equal to 6. Then x3 is equal to minus 8, y3 is equal to 8. Again x1 y1 means minus 1 by 2 and then 3. Now we have to multiply this term. This is half into, just multiply these two terms. See, minus into plus, minus 1 by 2 into 6. We are multiplying, right? So 2 1s are 2 3s are. Minus 1 into 3 is minus 3. Then minus into plus, minus 5 8s are 40. And then minus into plus, minus 8 3s are 24. First term is completed. Then we have to write the second term is minus of the second term. Right? Now the second term is, this is the second term, we have to multiple. See, minus into plus, minus 5 3s are 15. Then minus into plus, minus 8 6 are 48. Here we have minus plus, so we get minus. Here also we get minus 1 by 2 into 8. Multiply, right? So 2 1s are 2 4s are. So minus 1 into 4 is 4. Now simplifying. See, all the terms are negative value. So minus 3, minus 40, minus 24. Sum of this value is equal to 7 and then 6. Minus 67. All the values are negative value. So we have to put the minus symbol and add all the terms. That is 67. And here we have minus. And add these terms. Here we have minus 15, minus 48, minus 4. Sum of this term is 12. 12 plus 5 is 17 plus 1 is 67. And here also we have minus. So minus 67. Now remove this bracket, we get the value as this term is equal to 1 by 2 into, see here we have minus 67. If you remove this bracket, we have to multiply the symbols first. Minus into minus is plus 67. So plus 67 and minus 67 both are cancelled. Off into 0 is nothing but 0. Hence the points are given points are collinear. Therefore the points are collinear because here the area of the triangle is equal to 0. Then we can say it is a points are collinear. Students, exercise number 5.1 in coordinate geometry. Let's see the question number 4. Find the value of A for which the given points are collinear. See, the 3 points are given and the condition is given as the points are collinear. The points are collinear means all the 3 points are lies in a same straight line. If the 3 points are lies in a same straight line means then the area of the triangle is equal to 0. How? These 3 points we cannot make as a triangle because all the 3 points are lies in a same straight line. So there is no triangle is formed means then the area is equal to 0. So let me take it as by the condition the collinear is given. So let me take it as the first point A as 2, 3 and the B as 4, A and the C as 6, minus 3. Here area of the triangle ABC is equal to 0 by the condition collinear. So area of triangle ABC is equal to 0. Right? Now area of the triangle, we know the formula, that is half into x1 y1 x2 y2 x3 y3 again x1 y1. This term is equal to 0. Now let me take it as the first point as x1 y1 and then second point as x2 y2 and then third point as x3 y3. Now substitute the x1 y1 x2 y2 and then x3 y3 in this formula, then we get the values. That is 1 by 2 into x1 is equal to 2, y1 is equal to 3. Then x2 is equal to 4, y2 is equal to 8. And then x3 is equal to 6, y3 is equal to minus 3. And then x1, y1 again 2, 3. This term is equal to 0. Now I take this 1 by 2 to another side. If I take 1 by 2 another side means the denominator 2 is taken to another side means division should be changed into a multiplication. So here we have the terms 0 into 2. Right? Here we have to multiply these terms in LHS side. 2 into A is 2A. 4 into minus 3 is plus into minus minus. 4 3s are 12. Both having the plus symbol, so put plus. 6 3s are 18. Minus of the second term. The second term, this is the second term, we have to multiply this. See, both having the plus symbol. 4 3s are 12. 6 into A is 6A. And then plus into minus minus. 2 3s are 6. This term is equal to 0 into 2. 0 into 2 is nothing but 0. Now substitute this. Here we have 2A minus 12 plus 18. When we subtract this, we get plus 6. And then here we have the minus of the second term. Here we have 6A. 12 minus 6 is 6. This term is equal to 0 into 2 is 0. Now 2A plus 6. 2A plus 6. When I remove this bracket, we have to multiply the symbols, right? Here we have both having the positive value. We have to change into negative. That is minus 6A minus 6 is equal to 0. Here plus 6 minus 6 both are cancelled. then 2a minus 4a is equal to minus 6a is equal to minus 4a is equal to 0. Here plus 6 and minus 6 cancel. Here we have minus symbol as the biggest one, so minus 6 and 2. 6 minus 2 is 4. That is minus 4a is equal to 0. Here we want to find the a value. I take this minus 4 to another side. Then a is equal to 0 divided by minus 4. 0 divided by any number, we get 0 itself. Then a is equal to 0. Therefore, the value of a is 0. Students, exercise number 5.1 in coordinate geometry. Let's see the question number 5. Find the area of the quadrilateral. Right? Find the area of the quadrilateral whose vertices are given at quadrilateral means we know that 4 sides. Right? The points given as minus 9, minus 2. Minus 8, minus 4, 2, 2 and 1, minus 3. First we have to take the given points in an order. So let roughly we draw the graph. Let me take that this is x, this is y. In first quadrant we know that both the values are positive value. And then second quadrant we know that the first value is negative, second value is positive. And then third quadrant we know that both the values are negative. In fourth quadrant we get plus and minus, right? So the given points minus 9, minus 2 may be your, right? Minus 9, minus 2, right? Approximately this point is the minus 9, minus 2, and then minus 8, 4. Here we have this is the approximately this is minus 8, minus 4 lies in the third quadrant, right? And then 2, 2, this is the point, let me take this 2, 2, and then 1, minus 3, plus minus, here we have plus and minus, right? So it may be a point like this, approximately, right? We are taking only the approximate. So 1, minus 3, we have to take it in here, anti-clockwise direction. Here the first point is given as, let me take it as A. The second point, let me take it as B, and then here the third point is moved here, right? And then fourth point, see that this point I take it as C and this point I take it as D. Now take it in order, then let A as minus 9, minus 2, and then B as minus 8, minus 4. By taking the order, so I interchange these 2 points, right? Then C as 1, minus 3 and then D point as 2, 2. By that's why we are doing the rough diagram here. If you take that in a given manner means you get the negative values sometimes. If it is not a wrong answer, if you get the negative value means in the area of the quadrilateral or area of the triangle we get only absolute value only. If you get negative, just change it to a positive value, that's all, right? Now we see the formula area of the quadrilateral. Area of the quadrilateral. Here ABC is the area of the quadrilateral, right? The term is equal to half into x1, y1, x2, y2, x3, y3, and then x4, y4, again x1, y1. Here we are finding the area, so use square units. Shall I write this? This is roughly only we are doing that. So I write this. Now the first point we take as x1, y1 as A, x2, y2 as B, and x3, y3 as C, and x4, y4 as point D. Now substitute the values in the formula. Now this term is equal to half into, what is the point of x1? Here it is x1 is minus 9 and y1 is minus 2. And then the point x2 is minus 8, y2 is minus 4, and then the point x3 is 1, y3 is minus 3, and x4 is 2, y4 is also 2, again x1, y1, this is the point x1, y1, so minus 9, minus 2. Now we have to multiply the terms. half into, see how we have to multiple. First multiple this term. Here we get minus into minus plus 9 fours are 36. Minus into minus plus 8 threes are 24. Here both having the positive value. 1 into 2 is 2. Here we have plus and minus. So put minus. Plus into minus is minus. 2 twos are 4. Minus of the second term. See, first term is completed. Then put minus of the second term. The second term, this is the second term, you have to going to multiple. See, minus into minus plus 8 twos are 16. Then come here, plus into minus, minus 4 ones are 4. Here, plus into minus, minus 2 threes are 6. Here, minus into plus, minus 9 eights are, 9 twos are 18. See, next we have to simplify the term. This term is equal to half into, add the terms 36 plus 24. I just adding here 36 plus 24 and then 2. If you add, we get 6 plus 6, 12, 2 remainder 1, that is 62. Sum of this term is 62, minus 4 is equal to 58. Right? Minus of this term. Here we have the negative value as 3 terms, positive value as only 1 term, right? So minus 18, minus 6, minus 4. 6 plus 4, 10, 10 plus 18 is minus 28. Here we have plus 16. Now we have to subtract these two terms, we get highest value as minus, so minus 12. So minus 12. Now remove this bracket. Here we get the value half into 58. When you remove this bracket, we get minus into minus. First we have to multiply the symbol. Minus into minus is plus 12. So sum of this value is equal to 1 by 2 into 58 plus 12 is 70. Then divided by 2. 2 ones are 2, 35 sir. Then the area of the quadrilateral ABCD is equal to 35 square units is the answer. Hi students, exercise number 5.1 in coordinate geometry. Let's see the question number 6. Find the value of k. We want to find out the value of k if the area of the quadrilateral is given as 28 square units. The area of the quadrilateral is given, then whose vertices are minus 4 comma minus 2, minus 3 comma k, 3 comma minus 2 and 2 comma 3. Let me take it as the given points as A, B, C, D. Now the area of the quadrilateral is given and then we want to find out the value k. Solution. Let A point as minus 4 comma minus 2 and then B point as minus 3 comma k. And then the C point as 3 comma minus 2 and then D point as 2 comma 3. Now area of quadrilateral, here ABCD is the area of the quadrilateral, so let me take it as ABCD. Area of the quadrilateral is given as 28 square units, right? So this term is equal to 28 square units. Now we know the formula for area of the quadrilateral ABCD, right? Now the formula of the area of the quadrilateral is half into x1 y1, x2 y2, x3 y3 and x4 y4 again x1 y1. This term is equal to the area of the quadrilateral ABCD is equal to 28. So let me take it as this term is equal to 28. Now the first point we take it as x1 y1 and then second point we take it as x2 y2 and then the C we take it as x3 y3 and then the point D we take it as x4 y4. Now substitute the values of x1 y1, x2 y2, x3 y3 and x4 y4 in the formula. We get half into What is the point of x1? x1 is minus 4 and y1 is minus 2 and x2 is minus 3, y2 is k and then x3 is 3, y3 is minus 2 and x4 is 2 and y4 is 3. 2, 3, again x1, y1, right? So take that point minus 4, minus 2, this term is equal to 28. See, now I take this 2 to another side. It is in the division 1 by 2, right? I take this 2 to another side. Division should be turned to multiple. So here we get the value as 28 into 2. Now we have to multiply the given terms. I already take this 1 by 2 to another side. That 1 by 2 is turned to another side means we get 2 multiple by 2. Now the first term we have to multiply with this. Minus into plus, minus 4 into k, 4k. Minus into minus, plus 3 2s are 6. Both having the plus symbol, so put plus, 3 3s are 9. Here plus into minus, minus 2 2s are 4. First term is completed, minus of the second term. See, the second term you have to multiple like this. Minus into minus plus 3 2s are 6. Both having the plus symbol, so put plus 3 into k is 3k. Here plus into minus, minus 2 2s are 4. Minus into plus, minus 4 3s are 12. This term is equal to 28 into 2. Now simplify this. Here we get the value as minus 4k. 6 plus 9 is 15. 15 minus 4 is 11. So plus 11. Minus of. Here see we have 3k. 12 and minus 4. Both having negative symbol. Minus 12, minus 4 we get minus 16. Here we have plus 6. If you add this 6 with this number, we get minus 10 is the value. So 3k minus 10 is equal to 28 into 2 is 56. Now we take this minus 4k plus 11, minus 4k plus 11. Now here I remove the bracket here. When you remove the bracket, you have to multiply the symbol. Minus into plus, minus 3k minus into minus plus 10 is equal to 56. Now both having the negative symbol, so minus 3 minus 4 minus 3k minus 4k, so we get minus 7k. Sum of these two values is equal to plus 21 is equal to 56. Now I take this 21 to another side, minus 7k is equal to 56 plus 21 turns to minus 21. Then subtract this term, minus 7k is equal to 56 minus 21, right? 6 minus 1 is 5, 5 minus 2 is 3, 35. Now we have to find the k value. Then k is equal to, I take this minus 7 to another side. Already here we have 35. I take minus 7, it is in multiplication, take to another side, it will be divided. So k is equal to 7 ones are 7 5s are. Here we have minus symbol, so minus 5 divided by 1 is nothing but minus 5. Therefore, the value of k is equal to k is minus 5 is the answer.